In this project we will make our own audio player with ESP32. This project is a simple project to test a voice output from ESP32.
No one would have believed in the last years of the 19th century that human affairs were being watched from the timeless worlds of space. No one could have dreamed we were being scrutinized as someone with a microscope studies creatures that swarm and multiply in a drop of water.
No one would have believed in the last years of the 19th century that human affairs were being watched from the timeless worlds of space. No one could have dreamed we were being scrutinized as someone with a microscope studies creatures that swarm and multiply in a drop of water.
No one would have believed in the last years of the 19th century that human affairs were being watched from the timeless worlds of space.
I have made my own PCB board for this project. You can get the similar output by making a simple connection as shown in the figure. I have discussed all the circuit diagram and programming of this project. So, let us go to the video in detail. Starting the project with the introduction. We can see many projects in the internet to play music with ESP32 using I2S protocol. For that you need a separate SD card slot where you can plug in your SD card filled with music. You can play that MP3 file of that SD card with the help of speaker by using I2S protocol. In this project we are doing the same thing differently without using SD card module. In this project ESP32 based audio player, we have connected one of the DAC pin of ESP32 to amplifier and two terminals of speaker to amplifier. The audio output may not be loud, but this application shows the ability of the ESP32 board to play audio files. The above is the block diagram of ESP32 based audio player, which mainly contains power supply unit, controller unit, audio amplifier unit and speaker. We have used 5-volt adapter to power up our system. The audio amplifier is connected to DAC pin of ESP32, which are GPIO25 and GPIO26. The 2-terminal of simple 8-ohm speaker is connected to audio amplifier. This is the overall block diagram of the project, and it looks so simple. I have made 2 circuit diagram for this project. If you are designing your own PCB, you must follow the above circuit, where I have designed my own audio amplifier circuit using LN4890. If you are not familiar with the PCB design, you can follow this circuit diagram, where we are using LM386 amplifier module. The above circuit diagram looks so simple. You just need to connect few connecting wires in your module. VCC and ground of audio amplifier is connected to VIN and ground of ESP32 respectively, and IN pin is connected to GPIO25, which is DAC pin of ESP32, and 2 wires of speaker is directly connected to audio amplifier. Before going to the programming section of this project, we must have to do some board setup and library installation task. For that, open your Arduino IDE. We have used ESP32 Rover board in this project. We must have specified ESP32 Rover board installed in our Arduino IDE. I have already installed ESP32 Rover board in this system. If you have not installed it yet, you must obey the following instruction. First of all, go to my website, electronicsworkshops.com, and search for this project ESP32 based audio player. I will also place a direct link of this project in the description of this video. Open this project and go to the coding part. You can see ESP32 board link for Arduino IDE. Copy the link and come back to your Arduino IDE. Now, go to File and Preferences. You can see additional board manager roles there. You can just paste the copied link here. Now, go to Tools, Board, and Board Manager. Search for ESP32 in the search section, then you will get this interface. I have already installed it, so it is showing installed. You must install the latest version of ESP32 board here. We have just completed our first task. Now, we must download audio library in our Arduino IDE. In the same coding section of the project, you can get the link to download this library. By clicking to download here, you will get directed to this interface. You can see XTDAC audio library there. You can just click the download button to download it. After downloading the audio file, you must add that zip file to your Arduino IDE. For that, go to Sketch. Include library. Add zip library and include the zip file that you have recently downloaded. To confirm the installation of audio library, you can go to File, Example and look for XTDAC audio library. If you see this, you can consider that your library is included successfully. Here, all our installation is completed. And now we will see whether our audio library works fine or not by uploading the example code to our ESP32 board. Go to File, Examples, XTDAC audio library and open WAV speed code. I have already told that we have connected our audio amplifier to DAC pin 25 of ESP32. If you have used another pin, you can make a changeover here. Now, select the respective board and port from the tools and upload this code to ESP32. If your connection is made correctly, then you will be able to listen the audio output from your speaker.
No one would have believed in the last years of the 19th century that human affairs were being watched from the timeless worlds of space. No one could have dreamed we were being scrutinized.
You can check a multiple example from this library and listen the different output from your speaker. For adding your own audio file, you must obey the following steps. First of all, go to my website Electronics Workshop and search for the same project, ESP32 based audio player. After that, scroll down to Add Your Own Audio File section, which is just below the coding section. There you can see the download button. By just clicking the download button, you can download the code. Go to your respective download folder and extract your code.zip file. Open code.ini folder in your Arduino IDE. The final code of the project is included in code.ini section, and sound.h section contains the hex file of the audio. So, to add our own audio, we must change this sound.h file with the respective hex file. First of all, you need to select the audio file that you want to play in speaker. In my case, I have Googled and found these MP3 files from where I have selected and downloaded Hello Butthead. Now, we will see how we can change this audio file to hex file and use it in sound.h section. We must keep in mind that ESP32 cannot play the audio file of .mp3 format. To play audio sounds on the ESP32 board, we need audio files in .wav format. After that, download and install the Any Audio Editor app. We have used Audacity in our case. This app will be used to change the file type, sample rate, and other properties. Open your Audacity app. Then, go to File and open the latest MP3 file that you have downloaded.
Hello?
You must change the project rate to 16,000 Hz. Again, go to File and export this in WAV format. Another thing to keep in mind is encoding must be unsigned 8-bit PCM. Now, you can save this file. We have generated our WAV file. And now, our task is to convert that WAV file to hex file. For that, we are using another application called Editor. Open your Editor application. Then go to File and open your recent WAV file. Select these all by pressing Ctrl+A, then go to Edit and code this code in C format. Now, come to sounddata.h file in your Arduino IDE. Paste the hex code that you have copied earlier in this part. Go to beginning of this code and change the hex data to sample because the class declared in main code should be same in the header section also. Now, select the respective port and board to upload this code in your ESP32 board. After the code get uploaded, you can listen the audio output from the speaker.
Hello? Hello?
I have made a proper documentation of this project and posted it in my website. If you are interested going through it, I have provided the link in the description of this video.